about variables and constants in Swift. And I'm going to keep toggling between my presentation and working examples so you can see both the text associated as well as the working examples. Now, what are variables in Swift? Um, as with any other programming language, variables are means of storing certain types of data. And this is the kind of data you're going to store in a variable and then use later for access, display to the end user, computational, or post it using a REST interface to some backend service. Now let's look at Swift variables and see how they're different than other languages. We'll also talk about Swift's type inference and type annotation as we look at the working examples. For this, let's open up the playground. And I think as you would have seen in the slide deck already, the syntax looks a bit different. I think in the past we concluded that Swift syntax looks very much similar to like a C style language with bunch of optimizations on top of it. But the variable syntax doesn't necessarily looks like a C style in syntax. In C, C++, Java, or similar programming languages, generally you're used to a syntax like int x equals 0. Um, Now, in Swift, this is not a valid syntax, as you can see. Um, Now, what you need to do to define a variable in Swift is use the word var. That's a keyword. You define variables by using the word var, followed by name of the variable, and followed by the type of the variable. So you can say x is of type int, and that's a proper variable definition. Now in Swift, as I have mentioned again and again, you do not use semicolons to indicate that end of the line. The new line character is good enough to indicate end of the line, so you will not be adding semicolons at the end of the lines. This style of syntax, which is where x is of type int, is what we call as type annotation. This means that I'm explicitly telling that x is of type integer. Now, this is not always needed, and what you will see in Swift is this is not commonly used by Swift developers either. If they know the value of a variable upfront, they are not going to be using type annotations. What Swift developers will be using is what we call as type inference. And the difference is that you're still defining a variable, but instead of you explicitly going forward and declaring it of type int, you're just letting Swift know of the value. Now you're telling that y has the initial value of 23, all good. But as you do so, it automatically tells Swift that y is of type integer, int. And you don't need to explicitly declare it because it's obvious to Swift. And these types of shortcuts you will see throughout Swift, which means is wherever there is an opportunity to cut few lines of code where it's redundant, where the compiler can actually go forward and understand the meaning itself. Swift will not ask you to go forward and explicitly declare it, Swift will infer it. Um, and what I mean is that instead of doing so, if you really wanted to go forward and just say that variable y was type integer and the initial value is 23, is perfectly valid, as you can see, 23 as a result. But here, the fact that I'm explicitly saying that it is of type int is redundant, considering I'm assigning the value 23 and it's obvious to Swift that y is of type integer. We have now used both type annotation and type inference to define integers and use them. In the first example, we went forward and if explicitly told that x is of type int, we didn't necessarily assign it any value. And then in the second one, we actually assigned it some default value, and using the default value, Switch was able to type infer the variable as type int. And that's how you define variables in Swift. Moving ahead, let's look at the different types of variables that are available in Swift. Integers definitely was one type of variable, and now there are variations to integers, and I will not dig deep into them like in 32, 64, primarily because those are rarely used. Almost all iOS-based systems are now 64-bit, so by default, your integer is going to be 64, and you will not have to worry too much about it. But if you're interested, please do go over Apple's developer documentation and provides very interesting detailed view about the different types of integers and how different bit operating systems can actually affect them. But for all practical purposes, you've been using just int out of the box, so I will not dwell too much into it. Now let's look at doubles. We have done type annotation, type inference, and I hope you understand it. I will come back to it a couple of more times in this presentation, but I will not go into type annotation and type inference example for each and every type. Let's say that we are using a different example where integer was just our number of students, and we can just say that there are 20, and double basically was their average scores. And let's say that was 85.6. As you can see, I didn't really said explicitly that I am using average scores which is of type double. I simply set the value 85.6 and it has not error out. But how do I know that it is of type double? Because you can see the comment below and you can look at it and say, there is a floating point also which is present. What if Swift inferred this as a float and not as a double? So in case you want to be sure and you don't want to go by my word, which you should not, it's computer science, you should always test everything out. Swift has provided an operator which is called type of operator. So the type of function which has been provided by Swift uh, basically can be used on any variable to figure out what type the variable is of, hence the name type of. You can take type of function and pass it average scores, and as you will see, it will, once it's done executing, it will actually go forward and show that the type is of type double. Now I'm going to quickly check this configure to run automatically. It was just taking a bit time, so I wanted to be sure. And since we did it for double, let's do it for integers as well. Let's look at the type of students, and it is of type integer as we expected. Now let's say their average scores and then there is a median score. And for some unknown reason, you want to go forward and store the median score inside a floating point. So you define your variable and you said, okay, I went forward, define my variable, and I'm gonna look at the type of my median score, and it is of type double. It's not a float. And you're like, hmm. So will Swift automatically pick all decimal point numbers as doubles? Yes, that's the default inference. Again, Swift infers the type based on the value, and the default inference Swift is going to use is double. So yes, Swift is always going to infer it as double. So the second question comes as, then is there no way for me to actually assign floats explicitly in Swift? No, there is. You can always use type annotations instead of type inference and clearly state that your variable is of type float, and that's good. So you're like, yay, so now it is of type float, and as you can see, its type of has changed to float, so all good and dandy. Let's look at the Boolean variables as well, since we are actually covering all possible data types. And let's see if there's a variable like is enrolled. And if there's a in enroll variable and the value is supposed to be true, sorry about that, Swift is going to type inferred as of type Boolean. It can have values of either true or false. Now, next one we're going to look at is strings. Though I really don't need to keep digging into that, and I think you get the gist. But since we are trying to be comprehensive and covering all possible data types, let's look at it. We're going to define a variable for student name, and the student name we are going to choose is Tom Cruise. And we are going to check type of, type of, and we're going to pass a student name, and we're going to look at it and see that voila, the type of is of type string. Now, next example we're going to look at is character. Now, difference between character and strings and basically is that character is a single character, and it could be a Unicode character. So it can be a Chinese character, it can be a Spanish character, or it can be a normal Latin English characters like small a to z, capital A to z, digits 0 to 9, but it's a single character. That's keyword character. So let's define a character. I'm gonna say where, and I'm gonna say is middle initial, and I'm gonna say it is M. I don't even know Tom Cruise middle initial, so pardon me. Now, when I check the type of, are you expecting this to be of type character or type string? Now, it turns out to be of type string because again, like in the example of decimal point numbers, in the example where you're putting stuff inside double quoted strings, Swift is always going to type in for it as of type string. And if you want to explicitly use a character data type, you need to type annotate your variable as of type character, and now it's character data type. The good thing about doing so is that if you accidentally, let's say, fat fingered it to two characters, now Swift is going to add it out because it's going to say there, no, they're two characters. It's not a single character, so it has to be a string. There's no way this is a character, and of course, if you're doing all those checks and say, okay, I cannot convert a string to a character, so Swift is not going to allow that. So again, where type inference and type annotations are useful. Now let's look at two other different types of tuples, data types. They're tuples and optionals. And for optionals, I'm just going to dedicate a separate section or separate video so that it's an easy reference for folks to get to. But I'm going to cover the gist or the concepts here. So let's first start with tuples. Let's say I'm going to define a tuple. Um, Before I define, if you are supposed to assign a value and use type inference, the first thing comes in mind is that, okay, what is a tuple? How, before we go forward and define it. Now, tuple is an easy way to group a set of values. For example, if you have GPS lat and long coordinates, which are always going to be returned back, then both lat and long are going to be of type double, and they are going to be decimal point values. So it will be something like, and I'm going to just make some random lat and longs, 76.4 and 79.8. Okay. But the idea is that the values are always in a bunch, which is that's lat and long, but it's together. If someone asks me coordinates, the coordinates is not a single unit. It's lat or lat and long. So it makes sense to actually combine these two values as one unit, and that's where tuples are very useful. What you can use is, as I stated in this example, let's take the example of coordinates. You can define your coordinates, And you can just go forward and assign it the values which we declared above. And Swift is going to auto consider coordinates as type of tuple. And it's a type of coordinates. And let's see what's the type of coordinates is. Um, for some reason, it's just taking a bit of time, but you can see it is a tuple of type double and double as we had expected. Now, one of the cool, neat utility provided by Xcode is that when you start looking at complex type, and we'll cover this once we start looking at structures and classes, but when you start looking at complex types at that point in time, you can't really look at the entire data in this inspection area. But there's an sign or symbol, which is a quick look symbol, which will appear. You can click on it and it will actually show you the values which are contained in. So it shows you clearly that at index 0, it has the value 76.4, and index 1, it has the value 79.8, which is my x and y coordinates. I can always click on the expansion bar to actually see the detailed value. I can actually choose to close it as well. Now, since we're talking about tuples, it would be incomplete if I just tell that, okay, this is the way we can actually define a variable of type tuple. We can check it's of type tuple, but I don't talk about how you can access those values because they're two different values and you have one variable. So I'm going to go use the print example here. So let's say I'm trying to access values. So I'm saying coordinates provided are, and I hope you remember string interpolation, and that's symbol for string interpolation. Coordinates dot 0. I know that my 0th piece is my x and my first index is the y coordinate. So coordinate provided are 76.4, 79.8, and that's how we'll access them. Now optionals. So optionals, the way they differ is if there are certain variables inside your code which may or may not have a value. For example, you're trying to read a preference from NS user defaults, and I'm gonna try and stay away from specific terminologies because you might not be very familiar with what NS user defaults is right now. So let's say I'm trying to read some content from disk, but there is no guarantee that the content is present on the disk. And as a result, historically, most programming language, you basically have a function which reads content from the disk, and then you do something like, okay, if not nil, and if the value is y, then preference is true, and if it is false, then preference is false. But it means that there is a possibility the value is nil, and Swift is type safe, so it does not want you to go forward and just put if conditions everywhere for nil checks. As a result, Swift by default auto checks to see if a value of a variable can be nil, and if the value of the variable can um, is not defined as optional, then the value of the variable cannot be nil. So let's look at it with an example. So let's define a variable, and we're going to say optional var, and we're gonna, as the name suggests, it's optional. I don't even know whether the value exists, so I can't really initialize it with something pre-default. But let's say that I know that it's going to be of type string. So I'm going to say type string. But if I do so, then it's an optional value of type string. Um, okay, but so what's the difference? It's an optional var type string, but is it an optional or is it a string? It's a string. It's not an optional. For a variable to be an option type, you need to tell Swift that it is of type optional. And the optional type is present for all data types which we have covered so far. So we have covered integer, double float, boolean strings, character, and yes, and for all these data types, there's an optional version which is available. Now we're going to start with First, making sure that our optional var is of type string, and it is of type string, as you can see. To make it actually an optional variable, and I think I should have probably named differently so that I don't keep repeating optional. Um, but now what I've done here is that I have put a question mark at the end of the data type to indicate that it's an optional string. What it does is that you can see the default value changed to null. I remove the optional type and I press it, save button, you say there's no value present here, and it's a string data type. But if I assign it the optional string, the value is null. And the type is optional string type. So that's the big difference between the optionals and the regular data types. Optionals are allowed to be null, while normal data types are not allowed to be null. And um, here nil does different than null, which I think most people are familiar with in different programming languages. Does not mean that there's a null reference or anything. It's just that it's nil and there is nothing that is assigned to this optional variable right now. Now let's look at our slide deck once again and make sure that we have covered all the talking points. So we covered how to define the variables, we covered the fact how to do type inference, how to do type annotations. We have already covered all the Swift data types as they are listed, and of course, we pointed out that for in32, in64, unsigned, in32, unsigned, 64, we can go and refer to the Apple developer documentation. Yes, this is one node which I did not cover. Now, this is what's basically the coding style for Swift is. For all variables, we want to use camel case. As you would have seen, I have always started the variable name with a smaller case letter and a capital first letter of a subsequent word attached to the variable. So number of students, ONS gets the capital letter, the first letter of and first letter of students gets the capital one. This is camel case, and that's the structure which we follow in Swift. We do not put semicolons as it is provided. And generally speaking, the way you would see most Swift developers code is if you are using type annotations, then you will not have a space between the variable name and the colon. But post the colon, there will be a space between the variable name and the colon and the data type the variable is supposed to type annotate towards. These are the coding syntax, and if you're not used to it and you join a team with experienced developers, they are probably going to point you on these items. Another item, variable scopes. This is one portion which I think I'm going to cover in a separate deck with automated reference counting, so I'm not going to go over it right here. We can jump over our discussions to constants now. As we said in the beginning, we'll cover variable and constants. So we have covered the variables. Now let's look at what's the difference between a variable and a constant. We're going to start with string. And let's say we are going to define a string for customer name. And it's a variable. And let's say I have an initial value of Brad Pitt. Okay, so I went forward and did that. And it's a variable. Okay, all good. Now, let me first junk all this so that we can focus on our job at hand. Now, I can go forward and of course print the customer name, all good and dandy. I can actually go forward and change it later down the line. And came to know that okay, I was wrong. The hero in a given movie was not Brad Pitt, but it was someone unknown. And with a variable, as the name suggests, it's a variable, it changes. So I am totally allowed to go forward and change the customer name from Brad Pitt to someone unknown. All good. With constants, I can't really do so. Constants in Swift are defined with the keyword let. Let defines constants. Now, with let, you will go forward and say, okay, main actor, and you will say Brad Pitt. All good here. Now you can go for main actor and you can say someone unknown. And you will see that Swift is going to error out here and saying that, okay, this is a constant. You really can't change the value. Don't even try to do so. And if you really want the value to change, you need to go back and define your main actor as a var, not a let. So we can definitely get that done. But um, I think this gives the gist of an idea. Constants, you can assign the value once, and that's it. You can't really go forward and change it. Um, but you will ask me now is, well, does that means that my constant would always need to be initialized when I define it, which is I can always use type inference for it. I will never have to use type annotation because, well, the value can be assigned only once. So basically, if I use something like this, would that be raw? Would that mean that I must go forward and assign it some value at the end of it? The answer is no. And as you can see, I ran it and it worked just fine. And just saying that main actor is now someone unknown because you can define a variable to variable as let. But once you define a variable as let, all it means is that it's going to be constant. It's uninitialized now, but you will be allowed to initialize it only once. Once you have initialized it, you will not be allowed to change the value, which means line number 6, we go forward and define using type annotation. The main actor is the constant of type string. Then we go forward in line number 7 and say main actor, the value of this constant is someone unknown. Now, if in line number 8, I decide to have a change of heart and say, well, no, it's going to be Brad Pitt only. Swift is not going to allow that because it's a constant, and constants basically can't be reinitialized. I hope that clarifies what we're trying to do here. Now, another side note. Um, uh, you got the idea that, okay, variables, you can have the values changed, constant, you can't have the values changed. But you can come back and say that, okay, well, is if that's the only difference, why can't I define everything as a variable? And if I would need to change the value, I will change the value. If I don't need to change the value, then I will not change the value. That's a fair argument. So let's try and look at this with an example where um, we are defining the scopes. So let's go forward and say function, okay, assign, or let's say print customer name. Mhm. All good. And I'm gonna go forward and I'm gonna remove the comment. I'm gonna say, okay, this is my customer name and I am going forward and print the customer name. Okay, that's all the function does. And here I'm gonna call the function to print the customer name. Okay, all good. The code is going to run and then it's going to actually go forward and print the customer name, which is Brad Pitt. You can see the value being printed here, but you see that immediately Swift actually decided to throw me a warning. It's not an error, it's a warning. And if I expand it, it says that variable customer name was never mutated. Consider changing to let constant. Replace var with let. Of course, there's a fix button. I can press the fix button and change the value. And let's do that. But on rethought, why would Swift go the extra distance to notify me that, okay, well, this variable made sense to be let rather than a var? Why don't you go forward and change it to a constant from a variable? If the only difference is that I can change the value versus I don't change the value. Um, This is because it's just not a particular coding style or syntax which is good to have. Swift actually internally optimizes the lets. So their performance is actually more efficient than variables. So if you define a variable as type constant or is of type constant, then as a constant, not type constant, then Swift is going to optimize it so the performance of accessing the variable is better. So there's objective performance improvement of defining constants as constants, and that's why Swift goes the extra mile and wants you. And again, constants are not something that are going to be uncommon in Swift. As you start using Swift, you will see constant use all over the place. And if you are one of the developers who are bothered by the warnings, you are the ones who will let Xcode catch such issues for you and immediately fix them so that you have optimized your code for to be more efficient as well. And that concludes our discussion about variables and constants. And again, a quick wrap is the same example, which we have covered. Why does Swift does that? Because everything is supposed to be clear, explicit in Swift world, and Swift believes in throwing compile time errors where things are a bit ambiguous. This is again similar example where we have covered where warnings were actually thrown in case you go forward and try and define something as type where it makes sense to be of type let. Um, Again, this is the note that okay, you can actually go forward and initialize your constants later. You don't need to initialize on definition itself. And and the last part is basically saying that okay, you can't really use variables or constants before you have initialized them. And that's one thing which actually I missed. So let me go back and revisit this. Um, let's define a variable, say greeting, and it's going to be of type string. Let's say I want to use greeting and print it. Now, Swift is going to throw an error saying that, okay, you are trying to use a variable before it is initialized, and that's a big no-no. And that's good because that prevents me from making accidental mistakes like the ones I talked about where most languages keep going on doing null checks. Swift gives you compile time error and saying, okay, that's not allowed. You must initialize the variable before you go forward and start consuming it. And this is true for let and var both. Constants or variables, either one must be initialized before they are used. And with this, we actually conclude all our discussion about constants and variables. We will move on to optionals in a separate presentation.